back to class definitions, now that we have learned how to declare the member variables and member functions of a class, we can also assign them to be public or private, depending on how we would like to restrict access to our member variables as well as member functions. Therefore, we have the following syntax for a class definition. As you can see here, we use the class keyword followed by the class name, and for the definition body, enclosed with braces and terminated with a semicolon. Inside it, we have the following members, whether it is a member function or a member variable. We can assign them whether they are going to be public or private. Talking about declaration of an object, once a class is defined, an object of the class is declared just as variables of any other type. Again, we call those objects as instances of our class. Here's an example. As we can see here, we have a class bicycle with the following definition. And of course, to create two instances of the bicycle class, we simply declare two objects of type bicycle. Also, assignment operators can also be used with objects, just like what we did with structures. Here's an example. In this example, we declared two objects of type day of year, and for this object, using the setter function, we assign the following values to its member variables. Then, what we did here is to simply assign the object to another object, which means whatever is the content of this object will also be stored in the member variables of this object. Here's another example which demonstrates how to create a class and how to use them in our program. For example, we have the bank account class. In this case, it allows withdrawal of money, and it also includes all operations expected of a bank. In this case, we will use member functions to store an account balance, and we will also be able to store the account's interest rate. So let's take a look at this example. Here's the actual code for our sample program. I encourage you to try this for yourself and experiment with its code so you will be able how it works, and also to see how a class works in an actual program. Again, following the syntax for a class definition, we have the following. Okay. We set the corresponding functions, whether they are going to be public or private. In this case, we have the following accessor functions, and we also have the following mutator functions. And of course, we also have here a helper function, which is declared to be private. Okay. So here is the definition for our member functions. As you can see here, it still follows the syntax that we have mentioned a while ago, in which we have the return type, the class name, the scope resolution operator, and of course, the member function name together with the required parameters. This tells us that the following member functions belong to the bank account class. In this example, we call public members. In this case, recall that if calling a member function from the main function of a program, you must include the object name. And of course, using the dot operator, we can call its member function, which is declared to be public. And how do we call private members? As we will recall, we need a member function whenever we need to call or access a private member variable. In this example, when a member function calls a private member function, an object name is not used. As you can see here, we declared the member function fraction as private. In this case, we're only going to use that as a helper function. Therefore, whenever we need to call such function, we simply call them in this way. In this case, we simply call them by their function name, but they are not linked to a particular object. It's because they are considered as a private member function which belongs to this class. Now let's talk about constructors. A constructor can be used to initialize member variables when an object is declared. Just like a regular variable, whenever we declare an object of a class, we also need to initialize its member variables. We do so by using constructors. A constructor is a member function that is usually public. It is automatically called when an object of the class is declared, which means whenever you declare an instance of the class, which is an object, the constructor function is automatically called. And of course, a constructor's name must be the name of the class, and it does not return a value. So how do we declare a constructor? For example, we would like to create a constructor for the bank account class. Therefore, it can be declared as following. As you can see here, we have the same syntax for defining a class. And in this case, we are declaring our constructor. As you can see here, it is declared as a public function, and it also indicates the arguments that are required. In this case, these arguments will be used to initialize the member variables of our object bank account. And how do we define our constructor? It's still similar with how we define a member function. In this case, our intention is to initialize our member variables. For example, we would like to initialize our member variables with the following value. As you can see here, it's still the same. We refer to the class name, then we use the scope resolution operator, and of course, the function name. Since this is a constructor, the function name should be the same with that of our class name. Now, how do we call a constructor? We must take note that a constructor is not called like a normal member function. If we are going to do the following, this would not work. Instead, a constructor is called in the object declaration in the following way. As we have mentioned a while ago, a constructor is automatically called whenever we declare an instance of a class, such as this one. We declared an instance of bank account, an object named account1, and of course, using the constructor function, we initialize its member variables with the following values. As a result, this creates a bank account object and calls the constructor to initialize the member variables. And of course, just like what we did in our lesson about functions, we can also overload our constructors. Of course, since constructors are also functions, therefore, whatever that we can do with a regular function, we can also do the same with a member function, which is a constructor. Constructors can be overloaded by defining constructors with different parameter lists. In terms of difference, its version may have different data types, different number of arguments, or no arguments at all. Here's an example. In this case, we have a constructor which requires 2 arguments whenever it is called, or a single argument. And in this case, this one has no argument at all. And we also need to have the default constructor. A default constructor uses no parameters. That's what we saw in this example. A constructor which has no parameter is called the default constructor. For example, the default constructor for the class that we made could be declared in this way. And how do we define a default constructor? Here's another example. The default constructor for the class that we made can be defined in this manner. The bottom line is, the default constructor is used to assign the initial value or the default value for our member variables, which means whenever we declare an instance of our class and no parameter was used, so it means that we intend to use our default constructor, which is in this case, let's say we would like to assign a default value of 0 to our member variables. We must remember that it is a good idea to always include a default constructor even if you don't want to initialize your variables. So how do we call the default constructor? The default constructor is called during the declaration of an object. Let's go back to our examples. So let's say we would like to take a look at an example in which we use our default constructor. First, let's take a look at the declaration of our constructors. In this example, we have overloaded our constructor function and we have 3 versions of it. And this one is the default constructor. So let's take a look how we used our constructor. Okay, here's an example. In this case, we used the version of our constructor which requires 2 parameters. And in this case, we used our default constructor which requires no parameter at all. And here's another one, another example. So those are just some of the examples on how we can use our constructors as well as how we can use our default constructors. As you can see here, the primary purpose of a default constructor is to simply assign the default value for our member variable, which is in this case 0. And a while ago, you have seen the following code which initializes our member variables. And as you can see here, it's a bit strange since the assignment operation is outside our body. This is what you call an initialization section. An initialization section in a function definition provides an alternative way to initialize member variables. As you can see here, since we don't need to do some other things aside from simply initializing our variable, then we can do this in the following manner instead of having to write it in our function body. So this is what we call initialization section. Members with parameters can use initialization sections, as you can see here. And by doing this, we can still have some other routines inside our function body. In this section, we have learned about the basics of classes. We were able to describe the difference between a class and a structure. Although we have seen a number of similarities between them, although they may have similarities in terms of how we view them, but we must remember that a class is completely different to a structure. We now know the reasons why member variables are usually declared as private. As we have seen in our examples, we would like to restrict access to our member variables. Therefore, we need to declare them as private, and we can only access and change its value using member functions, which are either accessor or mutator functions. And of course, we also learned about constructor, how to create them, how to declare them, and of course, what is its purpose. Then finally, we were also introduced to the initialization section of a function definition.